That's a weird little song, isn't it? Hello. Hello. Hello, everybody. How are we all doing? Yes, welcome to what will be a bit of a weird stream. Um, kind of a lecture thing, sort of. I'm mostly doing it to make sure everything I'm about to say makes sense, because I want to do a written version of this. But yeah, I'm going to be talking about blending layers and blending styles and these sorts of things. The sort of things that you in digital art use a lot, but don't necessarily know what they actually do. You just kind of get a feel for what they do. You get me notebook. There won't be a test. Don't worry. I will go into the maths of it, but I will then immediately try and explain intuitively what the maths means. There's very little complicated maths. A few of the layers are kind of iffy, but teachers always say that. Yeah, I don't know what's complicated and what's not really, because I'm just used to it. But I went into the maths of these things because I like maths. I'm weird. And it changed how I thought about them, and I thought I'd share that because I feel like I understand them significantly better now. And I think I can explain it in a way that doesn't actually rely on the maths, but I thought I'll include it anyway, just to whatever. You can ignore the maths, it's fine. I'll try and explain it intuitively. So let's get some music up for the background. Not Final Fantasy VII, apparently that gets copyright struck. Hollow Knight's always a nice background, isn't it? So yeah, this is a bit of a niche stream. If you're not into digital art, this might not make a lot of sense, but it's the Plamps. Hello. Right. So yeah, let's put some music on. Okay, we'll randomize it so it'll just keep looping round as time goes on. How are you doing, Plamps? You alright? We're going to be talking maths. Right. So let's get rid of that for a second. Actually, let's put this up here. I'm organised, it's fine. I also don't even have my notes up. It's great stuff. It's a chibi. Hello. You had to stay at work late last night, so you intentionally stepped in this morning. Marvellous. See? Life taketh away and life giveth back, eventually. What am I looking for? I'm looking for this. Okay, so we're going to be talking about blending styles and blending layers and all these sorts of things. So let's do that. We're going to... For the sake of explaining what it is I mean, this is Clip Studio Paint for those of you who don't know, and these are what I'm talking about. These different styles you can attach to your layer to tell it how it's supposed to blend with the layers below. You may have used a lot of these, like multipliers, very common for people who want to do shadows. Overlays, a very nice one. There's also things like color burn and, you know, vivid light and all these sorts of things. We won't be going over all of them. We'll just be going over the ones that kind of make mathematical sense. And so, for example, things like pin light and hard mix, they're weird. They behave very strangely. We won't be talking about them. Things like hue, saturation, color, brightness, you can probably work those out for yourself. It's the other ones I'm interested in. Hopefully this will make sense for anyone who doesn't care about maths, but I will give maths. Can you move chat out of the way of the menu? Why is chat there? That's a really weird place for chat to be. Yeah, this. That's like floating in the middle somewhere. Stick it over there. We don't need anything over there. Yeah, so these are the layer styles and such. So you can see most of my screen, I think. Probably awkward setup, but okay. So first things first. If we're going to be talking about digital art, we're going to be talking about how color is made in digital art, and you may very well know pixels are made up of red, green, and blue little lights. If you stick your eye really close to a monitor, I don't know if it works nowadays. They're lots of pixels in a monitor nowadays, but you can see red, green, and blue pixels, and that's how I'm going to be thinking of colors. I'm going to be thinking of them as how bright the red, green, and blue is. We're going to be using the RGB sort of scheme. RGB. So I'm going to be thinking of colors as a triplet of numbers. This is true also in these programs. You can see there's a triplet of numbers R, G, and B. However, in these things, they tend to use 0 to 255. 255 being the brightest and 0 being black. We're not going to do that. We're going to go 0 to 1. The reason being is that the only reason they choose 255 is because this is an 8-bit system. You can use 16-bit systems if you want, and then it goes up to like 60,000. It makes more sense to think of it as 0 and 1. So In this particular instance, we have 0, 0, 0 is black. 1, 1, 1 will be white. And everything else is contained somewhere in between. So the extremes are obviously when you've got the R is 1 and the G and the B are 0, in which case the red part of the pixel is all the way on and the green and blue is off, so you just get red. Similarly, 0, 1, 0 would be green, 0, 0, 1 would be blue, etc. And then you get the nice combinations like 1, 1, 0, which would be yellow, I think. You can look all these up. 1, 0, 1 is magenta, 0, 1, 1 is cyan, I believe. So anyone who likes printing will know they're the base colors used in those. But it's additive, so the point being is that the higher these numbers, the brighter the color. And that's how all of these layer styles are defined, is they are defined by acting on these values. I want to translate this into hue, saturation, and value because I think they're more useful for artists, but the translation from RGB to HSV is quite a complicated transformation, and converting the formulas into that is something that's going to take me a bit of time, but I want to do it at some point. But for now, we're just going to be working in RGB. So does that make sense? This is the fundamental. When I talk about a color, a pixel of color, I'm going to be talking about this. Yes, full stop. You guess? I mean, like I say, you can mess around with the colors because, like I say, it's sort of RGB here. But again, instead of 255, 0 to 255 as it is in this particular instance, it's just 0 to 1. So 50% grey would be 0.5, 0.5. This. Like that. Which is a very handy colour to have for reasons that will become apparent as time goes on. Right, so that's a colour. It makes sense to you, but you have a comp-sci background, so yeah, I know. It doesn't matter too much if you don't understand this, but I'm going to be defining all of the formulas for the layers. In terms of these, again, you don't even have to pay attention to those. They will come with intuitive explanations, hopefully. The one other thing I will have to say with regards to colours is how to invert a colour. So you can do this in most of these programs by hitting Control-I to invert an image. That just makes all of the bright colours dark, all the dark colours bright, and it does so channel by channel. So what it does is, I'm going to denote this, if we want to invert this colour, I'm just going to put a little -1 up here. And all that means is you basically subtract the colour from white. So in this instance, white will become black, black will become white. Red will become, so for example, 1, 0, 0, which is red. If we invert it, it'll become 0, 1, 1, which is cyan. It's like taking a photo negative. It is taking a photo negative, basically. For example, let me just pull up a random picture. I'll try and give examples where I can, because, again, maths is scary for people. Let's get a picture I'm going to be using quite a lot. Here's a picture of my cat. There she is. And you can just invert the image thusly. This is what the inverted version of the image looks like. All of the, as it were, warm colours, the things close to red, become close to blue or cyan. This is not a fantastic picture because it doesn't have a lot of colour in it. The colours. Just with colour. Not particularly. Anyway, you get the idea. You understand the cat. Yes, this is a cat. If you invert the image, it looks like this. So, for example, this really bright colour here came from a really dark colour. Dark goes to bright. Reds go to cyans. Yellows go to blue, etc. So that's just inverting colours. And that's going to be pretty important as we go along, because there are some blending modes that behave nicely, but they only either darken the image or brighten the image. And if we want to do the same thing but the other way around, we're going to have to invert colours to do so. So that's just heads up, that's how you do it. Okay, so that's the basic setup. I'm also not going to be thinking of transparency. So these are just solid colours on a thing. If you deal with transparency, you're basically just saying, okay, here's the original color, here's the color if it was solid. Let's just sort of move between the two of those in a smooth fashion. So, yeah, throws transparency a bit. Look, transparency is very important, but in this particular instance, it's probably quite easy to work out that you could just kind of find a way in the middle. Kind of, again, for the maths, it's not that important. It's just trying to get it to be intuitive. Let's actually do something. Basic arithmetic. Basic arithmetic. There are layers that are nicely named. I'll use this notation for sort of having layers. So we'll have a layer on top, which is capital R, capital G, capital B, and then a layer underneath, which is small r, small g, small b. So this is the color of the layer below, this is the color of the layer above, and I'm going to put this one on there with the, well, with the normal layer style. This does what you expect, and the color you get out of it is whatever the color is on top. This is just sticking a photo on top of another one. It doesn't matter what's underneath, it's going to be the color on top. That makes sense, yes? Now, if we were to do something marginally more interesting with a style called add, fairly intuitively, it just adds the values of each individual channel together. Basic arithmetic. We can understand this. Now, because higher values are brighter, this is going to make the image brighter. If our add layer is just solid black, which is 0, 0, 0, this isn't going to do anything because you're adding 0 to a number, nothing's going to change. The brighter the color is, the brighter the result's going to be. So here's the picture of the cat. Here is a layer of solid black, and I'm going to set it to add. There it is. Nothing's changed. Literally no difference. But if I make it brighter, then the resulting image is going to get brighter and brighter and brighter and brighter. One of the issues with this is, as you can probably see, you lose detail. Yes, exactly, she's becoming the sun. The image is getting blown out, and the reason for this is we're just adding numbers together here. But if those numbers add up to something larger than 1, we can't deal with that. The brightest color we have is white, which is 1, 1, 1. So anything that goes above 1 is just going to get sent right back down to white. Or whatever it would be for that particular channel, RGB. There will be many pictures of cat. Cat will be very useful over the course of this. So the consequence of this is that, exactly, there's a ceiling function. You have to limit it to 1. And any color that goes over that value will just be snapped back to 1. It'll be clipped back to 1. And thus you lose definition. You lose details that you had in the original picture that you no longer have. So for example, there is another style. Grab the same color. B subtract does, again, largely what you would expect. It subtracts whatever the top color is from the original bottom color. Thusly wise. And because add and subtract are compositional inverses, you would expect if you add something and then take it away again, you get back to where you start. And subtract makes things darker, as you would expect. But again, if I just take this same layer and set it to subtract, we should be back to where we started, but we've lost so much definition that it doesn't work like that anymore. Because we clipped so much into the white here, all that definition is lost. We can't get that back. So this is the problem with add and subtract. You lose definition. You're guessing, yes, there's a floor function for subtract. If we do the same, we're losing a lot of definition in the dark colors now, because the subtract makes a lot of the colors that were already quite dark black. And then if you try and add it on again, we've lost the definition. Exactly, demon cat versus angel cat. Like I say, these should be the original color, but alas, they're not. But I suppose we could, if the color is black, you're fine, but the more you sort of introduce these things in, you lose detail as you go along. So add subtract are our very basic way of making things brighter and darker. Still a pyro fluff no matter what layer. Yes, indeed. Don't forget the claws. There are lots of claws in there. So, yes, these are our basic ways of making images lighter and darker. The problem is that if you're not careful, you will lose fidelity. And they also do so in a very linear and kind of boring way. So here's, if we're just adding a color, all the dark colors are no longer dark. They're kind of middling gray now. Everything gets pushed up the same amount. So the shadows stop looking like shadows. It doesn't... This is a linear function. You preserve contrast, but in a kind of unpleasant aesthetic way. So there are quite a few problems with using this. But then, it's basic arithmetic. You can't expect much. Also, subtract has a weird thing, which is that if you subtract black, which is 0, 0, 0, nothing's going to change. The brighter the color is, the darker the result's going to be. That's slightly unintuitive. So, yeah. You would expect the darker the color you want to be, the darker the result's going to be. We will fix that later, but for now, just know that it's a bit unintuitive. These both clip and they're unintuitive, so... clip. Linear. Same thing. Plus unintuitive. Boom. Basic arithmetic. The second part of basic arithmetic, as you may possibly recall, is to go from the additive to the multiplicative. So we're actually getting into useful layers now. Hooray! This is a layer. This is a blending mode I use all the time. It's called multiply. Guess what it does? Yep, it just multiplies. I'm going to use dot notation for multiplication. Actually, let's make this explicit for people who aren't familiar with the many myriad different ways of writing multiplication. You just joined, is this for advanced photo editing? I wanted to understand what all these blending layers mean, so I went down into all the maths and now I want to explain what I've learned because I feel like it's very helpful to know these sorts of things. Hello, Oobs, how you doing? So yeah, I'm just explaining what these do and how they relate to one another because I think it's very useful to understand. I will try and give intuitive explanations where possible. So multiply. Multiply is nice. A couple of little facts about multiply. Anybody who's used it will know that it makes things darker. The reason for this is if we're dealing with numbers between 0 and 1. If you multiply by a number that's between 0 and 1, your number's going to get smaller. Or unless in the case of 1, obviously it will stay the same. So in particular, if we multiply by white, just a multiply layer on top of our original photograph here of white, like that, and set it to multiply, nothing's going to change because we're multiplying numbers by 1, nothing changes. If you multiply everything by 0, which in this case would be black, 0, 0, 0, stick it on multiply, everything's black, because if you multiply any number by 0, you get 0. So we can go all the way from the original color to black, and we will darken everything in between. The question is, how does this behave? There's a very nice result, which is that if you have two numbers between 0 and 1, and you multiply them together, you will get another number between 0 and 1. As a consequence, multiply doesn't clip. You can't go below 0 or above 1 using multiply. So there's no clipping on this, which is very, very nice. Oops. So we've solved that problem. That's great. It's not linear. It's multiplicative, as you may possibly be able to ascertain, which means that it's kind of smoother in a way. So let's give some demonstrations. If I were to just take that sort of 50% grey again, ish. So this is what it would look like on multiply. It just kind of looks like a slightly darker version of the original image. However, if I were to set this to subtract, it's kind of gone a bit too far in places. Like you've got the clipping, but you've also sort of lost the relationship between the colors, if that makes sense. Yes, darker version versus demon version. So this is why multiply is superior in a sense, because you've kept all the detail, and you've kept the spirit of the contrast. I know that seems a bit weird, but it just, I don't know. You're compressing the brightnesses that you could possibly have, but you're keeping the contrast relations the same. Whereas with subtract, you're just shifting everything along. If stuff blows out, it blows out. It just doesn't look great. So it's, I'm going to say smooth. So there's a bit of contrast, and it's very helpful. This is very nice. Why black, white, yellow, and grey instead of red, green, and blue, which stands for RGB? Black, white, yellow, and grey? I'm talking about RGB. Above what? Who? Where? When? How? My equations. Oh, well, no, I was just giving examples of colours. Sorry, this was, so for example, there's another 0, 1, 1 is cyan. I was just trying to demonstrate what these numbers meant. So yeah, apologies about that. Okay, so multiply's nice. I use it all the time for shadows. It's very pleasant. Also, each individual channel works on each individual channel. This can be a good thing, it can be a bad thing, but in particular what this means is that if you have a picture which has a lot of greens and blues, but not a lot of reds, and you multiply it by a red colour, you're going to end up with something grey. And the reason for that is that if you're multiplying it by a red colour, your top layers, these numbers here are going to be close to 0. And your bottom layer, because it's mostly these colours, this is going to be close to 0. So this product's going to be close to 0 because this is, this product's going to be close to 0 because this is, and this product's going to be close to 0 because this is. So you're just going to end up with something that just loses all colour. This is particularly apparent when I do shadows. I tend to do a multiply layer over, so let's get a little example up. So if I were to take like something like this, for example, or, well, let's, oh yeah. Well, no, no, be more interesting than that. What can I paint this green? Cactus? Cactus is nice. So if I was just to do a sort of simple, sort of cactusy kind of thing, and say, oh, okay, I want to do some shadows on this, so I'll get my multiply layer, I'll pick a nice sort of shadowy colour. I like doing sort of reddy purpley colours, so something like that. And then I sort of go over it. The problem you end up with is that because your shadow colour doesn't have a lot of red going on, your shadow colour doesn't have a lot of bluey green colours going on, and your base colour doesn't have a lot of reds going on, your resulting colour's not going to have an awful lot of saturation, particularly if you sort of go in for an in-between sort of thing. So, hang on, let me show you a bit clearer. Okay, so yeah, so basically if you scroll through your various different colors for this, you can get something that looks a little bit more vibrant. So for example, that, which is, it's working with the greens, and the reason for that is that it's closer to a green. Or that's accentuating the blues. But if you were to go for something sort of in between, you would just end up with this kind of slightly grey, dull looking color. So you want to kind of avoid that if at all possible, because it just ends up washing out your image and it doesn't look as vibrant. So basically, if you're doing a picture and you want to do shading for it with a multiply layer, do bear in mind that you may have to use different colors for the shading over other different colors, because otherwise the shadows are going to come out grey in places and really vibrant in others, because the channels work individually. I probably should have picked very specific colors for this. How about... Boom, there we go. How about that? And then for our shadow, we'll do something like this. So yeah, you'll just end up, if you try and apply a red shadow to a greeny bluey object, you'll end up getting something close to black because the colors just wash out. So that's just a quick takeaway from that. I say quick, it took me about 10 minutes to explain that, but you kind of get the idea, maybe. Does that make sense? Choose your shading colors carefully so that they actually work with the color underneath, because these things all work independently of one another. But otherwise, multiply, very pleasant. Good old layer, gets a big tick. Your fried brain got it, okay. But it makes things darker, which is nice if you want to do shadows, but if you want to do highlights, you're going to want to make things brighter. Not only does it make sense, but this is bloody interesting. I'm glad. We haven't got to the bit I think is interesting yet, but here we are. So if we want to make things brighter, in a way that isn't terrible, like add, we want something that works like multiply, but for bright colors. And your first port of call, logically, would be divide. Because divide is the compositional inverse of multiply. So if you do one and then the other, you should get back to where you started. So R divided by R, U by G. Sure, hearing things sound interesting, but your brain is regretfully in no thinking mode. I will upload the VOD if you wish to go through this at any pace you desire. I decided to do this as a stream so that if you want to ask questions, you can, and I encourage it, please. If something's not making sense, do tell me. You wish your brain could focus more today. I will try and make things as intuitive as I can. I will show you, I know this is probably going to put a lot of people off, but this actually really helps to have a visual aid. I will show you some graphs later. Again, that sounds horrible, but it is actually nice to have a visual comparison for what these things mean. We can play around with them. They're not just going to be, you know, here's a graph and some numbers. You haven't seen a graph in a long while. There'll be 3D graphs, so they're not going to be flat things. Hopefully they make sense. They'll certainly make sense for the later things. 3D graphs, oh yes. But yes, so multiply works really well and really nicely, and it darkens pictures. So we want something that does the same for how do 3D graphs work? They're surfaces in 3D space, or they could be lines. Any less than three-dimensional. Well, you could also have a solid three-dimensional object inside a three-dimensional space as a graph. Is that a graph? No, I think actually to be a graph, it has to be a parameterized surface. So, cube graph, you'll see. We'll do it later. Divide. So does divide do what we want? The short answer is no. Lots of clipping. Very, very high contrast. Any computer scientist, mathematician will tell you dividing is very badly behaved, particularly near 0, and we're dealing with numbers between 0 and 1. So that's not great. If you divide by a very, very small number, a number very close to 0, your answer is going to be very, 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 very big. And we don't go above 1. So that's a problem. You have a question, maybe you missed it, but what exactly do you mean by clipping? What I mean is you lose fidelity. A lot of, so for example, let's go back to this, but this as an add. What I mean by this is all of these colors here are distinct, but when I add a value to them, they're going to get numbers above 1. And when they get above 1, we're going to have to clip them back down to 1 because we can't go above 1. And what that means is that all of the colors end up being the same thing, which is white. So that's what I mean by clipping. Is everything clips back down to white or clips back up to black. Because the sum goes too far, so you're going to have to bring it back down to values we can deal with. And that causes you to lose fidelity, and it's problematic. So that's add, but let's do it with divide. Where's divide? So here's divide. It's higher contrast, as you can see, than the ad was. You understood that part? You think you just missed it, called it clipping? Yes, I'm calling that clipping. I don't think there's a particular word for it. Arguably, this looks nicer, and that's because it has the high contrast nature to it. So the really dark colours stay really dark, at least for now. You're blowing out the white colours. Again, let's switch this back to add. With ads, these are getting all sort of washed out and grey, but with divide... where's divide? The order with which they appear in this is weird. It's the emo MySpace filter, yeah. This is your Instagram filter. We will actually... Filters, very, very important for divide. I'll get to that. And it looks very blown out, and... Again, so it's kind of like just a higher contrast version of add. And again, if you want to make things... Divide has the same problem as subtract, but the other way around. The darker the colour you're dividing by, the brighter the end result's going to be. So if we bring this colour down and down and down, everything blows out, and we lose all of the value. Everything's just going to get far too bright. So yeah, the clipping occurs, it's back. And again, look, the dark colours are still kind of there. Whereas if we did this with ads, they'd be almost white by now. So this is what I mean by high contrast clipping. So it keeps the dark colours dark for longer, but it still blows things out. So divide's not very nicely behaved, particularly if we divide by black, we just get white. So good for creating a light source. Or, and this is the thing that's actually very useful, I think, is if you think about what divide does, the first thing you might learn about division is that if you divide a number by 1, nothing happens. You get your number back. The equivalent, and what that means is if we divide by white, if we divide by white, nothing happens. We get the original image back. However, an equivalent statement would be that if you divide a number, a non-zero number, by itself, you get 1. So dividing any number by, divide 5 by 5, you get 1. If, I have 5 apples and 5 people, I divide it amongst everyone gets 1 apple. It's an even split. What that means in this instance is if I divide a colour by itself, I get white. But I don't get something above white that I clip back down to white, I get exactly white. And what this means is if you look at your picture and you go, the colour in this picture isn't great. It's tinted, the lighting is a bit off. This was taken in a room where the lighting was very yellow. I know this cat's supposed to be white, as according to this particular image, though she's kind of beige. But if I were to put that colour on a divide layer, like that, suddenly that's the new white. And everything that was that colour is now white. And every other colour is pulled in that direction. So this is great for detinting images. If you know what colour white's supposed to be in your picture, if you divide through by it, you can just detint it. I learnt this while looking at these things, and I'm blown away by this because I never use divide, and this is amazing. So I messed around with a slightly more complicated example earlier, which is this. I found this on the internet. This is again sort of tinted a kind of pinky colour. So if I were to say, okay, I want this to be white, this seems like the colour that should be white. So this is the colour I just picked, and then I divide by it. We get something that looks a little bit more natural. We can mess around with it if we want. Let me bring it a little bit darker. And you can take the tint out of a picture. If somebody's put a tint on. Again, by doing this, you are going to blow the colours out a bit. Again, like there's a lot of detail being lost over here, which is a shame. But you don't have to divide by one single colour if you don't want to. You can say, oh, let's make this a little bit brighter over here, just so we get that. We don't lose our values there, and then everything else can kind of stay as it is. You can mess around with it. It's just really nice for detinting. So I've learned a new respect for divide from doing this. That was one of the things I really wanted to share with people because it's very cool. Detinting, good job, divide. You do good things. Hello, cactus. So yeah, divide, it has its uses, but for the purposes of just sort of doing general art, it's got a lot of problems. It doesn't do, in particular, it doesn't do what we want an opposite of multiply to do. Magic, divide the witch. So yeah, it's nice. Nice for detinting. Or if you prefer, tinting. So these are the basic arithmetic ones, but we haven't quite filled out our set, what we want to do with these things. So let's make some other layer styles from these. In fact, the only two layer styles we need to know are add and multiply. We can get everything else from those. As follows. So we got those. So we want something that does to brightness what multiply does to darkness. It's smooth, it doesn't clip, it's got some nice contrast going on. We would like that, but for bright colors. We can't get it from divide. So what we're going to do is we're going to trick multiply into thinking it's acting on bright colors. Into thinking it's acting on dark colors when it's actually acting on bright colors. What do we use for highlights? I will now explain. So what we do is instead of a dark color going into a multiply layer and coming out darker, what we're going to do, darker. What we're going to do is we are going to take a light color, invert it, as I was saying before, so turn light colors into dark colors into light colors. It will now be dark. We'll apply multiply to it. It'll get darker. We'll invert again, and we'll get something which is lighter. So we get what we want by tricking multiply into doing what we want in the first place. So multiply only works by making things darker, but if we invert the inputs, then do multiply, and then invert back again, we can make it do lighter things. So, by way of example, here's my cat again. Let's say, let's get some pictures. Something that actually sort of looks... Here's Pikachu. Bit weird. So yes, I'm gonna have to rasterize this. Give me a second. Right. So suppose I want this Pikachu overlay to make this brighter. Obviously at the moment it's gonna make things darker. So what I'm gonna do is I'm going to take copies of these two layers. I'm going to invert both of them. Sorry, these just normal layers for now. I'm going to invert both of them like that. Set the top one to multiply. By the way, technically you can do these either way round, because multiplication is commutative, so A times B is the same as B times A. So it doesn't matter which one's on top, so long as that's the multiply one. So we're going to multiply it like this, merge them down, and then invert back. So now the Pikachu has made the image brighter, because we made the multiply think it was working on dark colors when it was actually working on bright colors that had been inverted. Does that make sense? So what we're going to do is we're going to use this trick a few times. It's very nice. So we're going to take R, G, B, small r, small g, small b. And we're going to, this is slightly complicated looking formula, but it's exactly what I just said. We're going to take our inputs and multiply them together. So it's going to be R times R. But we're going to invert the inputs first by subtracting them from 1. So both layers we're going to need to invert. And then once we've gotten this value, once we've multiplied them together, we'll subtract the answer from 1. So we get the kind of effect that we want. And then we do the same for G and B. This is called screen. Why it's called screen, I have no idea. But screen is effectively the opposite of multiply, which you might think would be divide, but kind of... I call this the functional inverse, because it's doing the same function, but in the opposite way. And if we go here and take our original images here and set this one to screen, values here, then we should get, here we go, I'm toggling the one we made before on and off. It's exactly the same. We just did screen manually with a multiply. So a lot of these blending styles are just things you can do yourself. It just saves you a little bit of time. Show your work type of thing. Exactly. I just showed you how to make screen. So that's nice, I think. It's nice to know that screen and multiply are kind of, opposite sides of the same coin. It's a shame they don't have a similar name, because I never would have worked that out myself. But there we are. We can do a similar thing with add. So multiply and screen are kind of like, use this to denote the fact that they're sort of functional opposites. We can do the same thing with add if we want to. Which is what we're going to do with this is we'll have, so we add together our two inputs, but first we subtract them from 1. We invert the inputs and then we invert the results. We can simplify this a little bit to be, what would it be? Brackets. It will be R plus capital R minus 1, and then G plus G minus 1, B plus B minus 1, or if you prefer, R minus 1 minus R. G minus 1 minus G. Don't have to worry about the maths of it, it's fine. In particular, what this is, you can write this in several ways. You can think of it as doing a subtract, but inverting your input. So do you remember when I said the subtract works the opposite way around you might expect? The brighter the color, the darker the output. This fixes that problem. You just invert your input. So now, with this value, with this blending style, the darker the input, the darker the output. So that makes sense. This is called linear burn. And for that reason, add is occasionally called linear dodge. So again, we can... you did math today, you reverted a formula, and your colleague was like, no, that won't be right, you have to calculate it manually. And guess what? It was right, yeah. Maybe it has to do with screen printing. That's what I assumed, yeah. So things like the burn as well is to do with like burning film and such. So if we do the same sort of thing that we just did, but we... so yeah, we want to do the opposite of add, don't we? So we invert our inputs. We set this to add, which is going to make the image brighter. We then merge them together. And then invert the output. The image is now darker and rather scary. This is the same, hopefully, as if we were to just set it to linear burn. There. Anyway. So you can make your own linear burn at home, if you so desire. We can also do exactly the same thing, again, by, as I said, taking our two layers, inverting only the top one, subtracting it, wherever that is, subtracting it, and then merging together. It's the same thing, that's just a quirk of maths. Don't worry about it, it's quite nice. So yeah, there are various different ways to create a linear burn if you so desire. I don't really know what use linear burn is, because I personally find color burn does the same thing, but better. These things, because this comes from add, it has clipping, it's linear, as the name would suggest. You're going to ask if you needed to invert the bottom layer for it to work. Not for this, because that's what I said, is that in order to get linear burn from add, we have to invert both layers, add them together, and then invert again. But to get it from subtract, we only have to invert the top layer. So linear burn is basically subtract, but in disguise. It's exactly the same thing, you just invert your top layer. So they're essentially equivalent. It's very interesting, but it's hurting your brain and making it hard to get drawing done, so you think you'll watch the VOD later when you can take it in properly. I'm glad it's interesting at the very least. I'm sorry it's a bit much, but have a good time drawing. Oh, hello. Apparently I left the chat room. Strange. So yes. Stream hasn't gone down, has it? Hope not. Nope, still here. Good. Okay, so funnily enough, this act, do you remember the effect of this essentially is to make subtract make sense? Because it's unintuitive, because if you input a brighter color on a subtract layer, the image gets darker, it feels backwards. We have the same problem with divide, and we can do the same thing to divide. So if we define RGB acting down on small r, small g, small b, and we just define this to be what happens if we invert the top layer first, only the top layer, and then divide. So this way, brighter colors will make the image brighter. This is color dodge. Color dodge is exactly the same thing as divide. You just invert your top image first. They're identical. Again, we'll do this with this very, very strange example. So this is our normal copies. This is what happens if I color dodge, which is there. It's very blown out and bright because it's basically divide. But if I do first, if I invert the top layer and then divide, I can never work out where any of these are. There it is, right down there. That should, if I've done my job correctly, yes, should be the same. So let's merge these. Boom. There we are. And it's identical. Color dodge and divide are the same thing, you just have to invert the top layer to get between one or the other. Your brain is also barely able to grasp it, that's just because philosophy shut it down with sudden physics. So that's yeah, philosophy and physics tend to collide. And then from here, you can get, in the same way that linear dodge gave us linear burn, by applying this sort of multiply to screen effect. Because again, color dodge will only make things brighter, divide only makes things brighter. If we want something like color dodge, but that makes things darker, we do our little trick of inverting layers, combining, and then inverting back. RGB, and we call this color burn. So what that involves, so this, I should make this explicit. This is R divided by 1 minus capital R, G divided by 1 minus capital G, B divided by 1 minus capital B. It's the only difference between this and divide is that we have made the colors from the top layer inverted. That's it. In order to get this one, we have to do this, but invert the colors. And remember, if you invert a color and then invert back, you'll get back to where you started. So if we invert this bottom color down here, we'll just get capital R. So what it'll be 1 minus R, which is the inverted version of that, over the inverted version of this, which is just capital R. And then the same 1 minus G, capital G, 1 minus B. This is color burn. It's just the opposite of color dodge, essentially. Burns and dodges, they go together. Color burn is very nice because it makes things look like you're burning them. And it's named after what happens if you used to slightly burn film, it would make it darker. Seems a bit of an odd thing to do, but apparently that's the thing they used to do. Dodge those burns. Yeah, if you dodge a burn, you should go back to where you started. Actually, no, I don't think that's true. No, they're not compositional inverses, they're functional inverses. That's different. You can't dodge a burn and expect to be back where you started. So yeah, these are all the relatively basic layers, because all of these make something brighter or they make something darker. Now let's get greedy. Let's say we want to do both at once. Let's say we want a layer that makes things brighter when we want and that makes things darker when we want. How are we going to do that? Please burn the cat because you want a visual. Fair enough. Oh, hang on, it's inverted, sorry. That's color burn. I can show you how to do that. It's exactly the same thing as before. If I set this top layer to normal, so in order to get color burn's the opposite of color dodge, the functional opposite. So we invert both. We set this to color dodge, which is basically divide, but with better inputs. Merge them together, invert, we should get color burn. Okay. Who knew a picture of Pikachu and my cat would be so helpful? So yes, these are all the layers that do one thing. And they do these things relatively well, depending on what you want. I know a lot of people who do all of their highlights with color dodge. I try and avoid it because of all the clipping, but yeah, these things happen. Right, hybrid layers. I'm probably going to need. Let's just start there. Are they layers, styles? Hybrid blend. Like I say, sometimes we want a blending mode to do both things, to make things brighter and to make things darker depending on what we're using. There are several that do this, but the way that, and the most common of these at the very least, that you may use and may know of is overlay. Overlay, it is possible with an overlay to make something brighter and it is possible to make something darker. So if I were to get rid of this, I'll go set up a new overlay layer. This is a bit of a mess now, but here we are. If I take a very bright color, like white, I can make the image brighter. And if I take a very dark color, like black, I can make the image darker. So overlay does both. How does it do both? It basically does both by stitching together multiply and screen. This is why I wanted to introduce them as opposites. So this one's going to look a little bit complicated, and this is why I want to show you the graph, because the graph's quite nice. What you do is, in the red value, you say that it's going to be... I can never remember which way around this is. Hang on, I have notes. One or the other. I think it's a screen when it's bright and it's a multiply when it's dark. But, oh, it's a multiply when it's... Yes, okay. So what you do to the red layer is you say it's going to be a multiply layer. But in order to make this stitch together properly, you're going to scale it by multiplying it by 2. And the reason you're going to do that is because it's only going to be a multiply layer if the layer below is sufficiently dark. This sounds very strange, but bear with me. So if the color below, the red value of the color below is less than a half, you're going to treat this a bit like a multiply. If it's bigger than a half, or equal to, it doesn't matter, these two formula fit together at a half, they're identical. You're going to treat it like a screen, but again, you're going to put in a little factor there. So you're essentially stitching together, this is a multiply, and this is a screen. You're essentially stitching together a multiply and a screen layer, so that you can do both, but with kind of half of the effectiveness, which you have to do by sticking in this particular value. And then you do the same for G and B. Again, these are completely independently interacting with one another. Again, this is quite difficult to explain, but again, the point is that it allows you with bright colors to make the image brighter and with dark colors to make the image darker. So you can use an overlay to do shadows and highlights if you want. I tend to use it just for highlights, but I've never really experimented. So now I know this, I might give it a go. Overlay, however, has a bit of a problem. And that is what happens when you're in the middle. When you meet this particular intersection. So basically, the way you can think of this is overlay is a Frankenstein's monster stitched together of a multiply and a screen. But if you're in the middle, if you have a color that's in the middle, so R, G, B, and you're going to overlay it on top of, let's say, a 50% gray, completely 50% gray color. Then what's going to happen? You are going to this is where these two things sort of intersect. If you input your R value, your lower R value, as a half, then either you can look at this formula, in which case you get 2 times a half, which is 1, and then you just get R. 1 times R is R, capital R. Or here it's going to be 1 minus a half, which is a half, times 2, which is 1. 1 times 1 minus R is 1 minus R, and then 1 minus minus R is capital R. You're just going to get your original color. So the point is, you can get literally any color you want out of an overlay layer if the layer below is a 50% gray. It gives you complete tonal control. You can make it you can make it white, you can make it black, you can make it magenta, you can make it whatever you like. However, that's not how these two functions here work. Normally. They happen to work at that particular instance, but if you have a very dark color underneath an overlay layer, you're not going to be able to make it very bright. If you have a very bright color underneath an overlay layer, you're not going to be able to make it very dark. As I said, I just put white on an overlay layer. This eye color has barely gotten any brighter. These have positively blown out to all sorts of things, but this black, still kind of black. Similarly, I put this black over the top of what should be a kind of white. Let's do my divide trick. There we go, this is our undoctored image. And this black is almost barely affecting the white fur. So this is the big limitation of overlay, is that it works really well if the colors underneath are kind of 50-50. But if they're too dark or too bright, you don't have much control. You can't make them significantly darker or significantly brighter. I'll show you that visually later on the graph. That's why I wanted to do the graph, because it makes more sense when you see the graph. But for now, just know that sort of complete control here. But that's a weird sticker, wasn't it? Yeti lamp? Hello, Crow, how you doing? But if you overlay on top of a dark color, you're not going to be able to make it very bright. You can make it as dark as you like, but you can't go very bright. And this is an issue I've had when I've been shading things. So I use, like I say, I use overlay for highlights. But the problem is if you have an image, so for example, if you have a character who's got like a bright t-shirt and then black trousers, and you try and do highlights on them, the bright t-shirt, the highlights can blow out, but the trousers, nothing will happen. You'll get very little change. I want to try and open something up that can demonstrate this. How about... Okay, how about this? So this is the Crimbo sticker from, or the magnet rather, which should be working their way to Patreon thingy-bobobs. So let's look at... I've got a lot of layers here. It's very badly sorted out. Try, don't look. Okay, so here for example. So this is the highlights for this, for Rufus and Malachi. If you look at the highlight here, the highlight is basically the same as the original color when I stick it to overlay. But if you look, this is the original color just on normal. So you've got this sort of yellowy, bright yellowy color being used as a highlight. If I set it to overlay, notice that it's still pretty much the same on this green because it's quite a light color. Hello, Kiro, how you doing? It's still pretty much green on this. Oh, sorry, it's still pretty bright on this green color because it's quite bright. It's almost white on this, but if you on this darker color down here, it doesn't get very bright at all. And if I make that color even darker, you can see it's barely having an effect now. I haven't changed the overlay layer at all while doing this. So you don't, if you are trying to brighten something with an overlay layer and the layer below is quite dark, you can't brighten it very much. You don't have much control at all. Whereas if it's in the middle, you've got complete control. And if it's really bright, you can't make it very dark. So yeah, this is the problem I've encountered. And this is why I tend to make my, you know, like I say, I just had to sort of turn this down to show you what it was. I would like this to be a darker color, but in order for my shading to make sense, I tend to make all of my colors close to middle, just to try and make sure that I can avoid these things. And now I know what they are because I looked into the maths of it. And similarly for light and dark. So how do you solve this? How do you solve this discrepancy between having complete control in the middle and almost no control at the ends? There are two ways of doing this. The first is to make even more Frankenstein's monsters by basically doing the same thing. And by basically, I mean exactly doing the same thing. What am I doing? By doing exactly the same thing, stitching a multiply and a screen layer together. Precisely, exactly, unchangedly as it was before. Not going to change any of the formulae whatsoever, except instead of doing this when the color below is less than a half, I'm going to do it when the color above is less than a half. So whether or not you're working with a multiply or a screen will be determined by the color you have chosen to put on top. And that gives you complete control because you know exactly what color you're putting on top. And this is called hard light. Hard light, in terms of maths, is exactly the same as overlay. You're just giving all control to your color on top. It's much higher, it's a much bigger difference. So for example, if I were to go here and set this overlay layer to hard light instead, you can see now, all of a sudden, popped right out over the dark colors. We have full tonal control, ladies and gentlemen. Whereas with overlay, it didn't have much of a thing. So if you want full tonal control when you're shading, use hard light. Bear in mind it's called hard light for a reason. It's quite strong. So you might have to be a little bit more careful with that. But yeah. So that's what hard light is. This is basically the same as overlay, but it depends on the color you're using on top rather than the color you have on bottom. The opposite end of the spectrum would be soft light. Any fans of Red Dwarf may know these two things should be connected. Soft light, funnily enough, has almost nothing to do with hard light. It's just a solution to the problem in a different way. So again, the problem was that when we were about a half, we had full tonal control with an overlay. But at the ends, we didn't have much control at all. Hard light solved that by giving us full tonal control everywhere. We can do whatever color, wherever we want. Soft light goes the other approach, and it says, maybe let's not make the middle quite so extreme. Maybe let's have it a much more gradual slope. So you don't have full tonal control in the middle, you can make it a bit brighter or a bit darker, and you can do that pretty much everywhere. And that's why it's called soft light, is it doesn't have a huge effect, but you also don't have that huge discrepancy. You're back with Cereal and Calf, fantastic. Now soft light, the problem with soft light is that soft light doesn't actually have an established formula. I think every program uses its own, but I'll show you the one I like because I think mathematically it's very pleasant. The one Photoshop uses is very complicated and very messy and I don't like it at all. But this one's very nice. So what we do is we take our multiply. Hang on, let me just make sure I get this absolutely correct. Yep, good. So we take our multiply. Instead of splitting it up into two formulas and stitching it together, we're not going to Frankenstein's monster this. We're going to smooth it all out. So we'll take a multiply, and we will take a screen. This is our mult. And this is our screen. And what we're going to do is we're going to add a smoothing function between them, so that when it's fully dark, we will be multiplying, and when it's fully bright, we will be screening. And in between, we will smoothly move between them. So we're going to put 1 minus r in, and then an r here. This is our smoothing function. So when r is equal to 0, this will be 1, which means we'll have this multiply function here, and this will be 0, which means this will go away. So it will just be multiply. When r is equal to 1, this will be 1, so we'll have this term, and this 1 minus 1 will be 0, and we'll get rid of that. So it does the same thing of splitting up these two functions, but it does so in a very gradual way. And that's why it's soft light. And soft light ends up being a nice sort of compromise. It looks more like an overlay, but with the edges clipped. It's just a smooth overlay, so it doesn't have a huge sort of difference. One interesting thing about all three of these, overlay, hard light, and soft light, is that if you put in a 50% grey over the top, nothing happens. So here's the picture of the cat. Let's grab our 50% grey. Boop. On an overlay, it does absolutely nothing. On a hard light, it does absolutely nothing. Well, kind of does absolutely nothing because slight discrepancies in colour and so on and so forth. And then soft light should, if they use the right formula in this, do absolutely nothing. So 50% grey is the middle ground. That's where the two functions meet as to whether or not you're doing a screen and a multiply, and so they agree to disagree in the middle. Anything above, you get your brightness, and anything below, you get your darkness. So that's how they sort of relate to one another. And there was one other thing I wanted to talk about. Oh yeah, I suppose we can talk about the other Frankenstein's monsters, can't we? So we've just been doing this with multiply and screen, because multiply and screen are functional opposites. We got screen from multiply by inverting the inputs, multiplying, and then inverting the output. We've done that before. It wasn't just multiply and screen we did that with. We did that to get linear dodge and linear burn, or add and linear burn if you prefer. We can make exactly the same Frankenstein's monster with add and linear burn if we want. That's called linear light. Which we have here. So linear light is the Frankenstein's monster of add and linear burn. Let's sort of show you kind of what that looks like. Again, 50% grey, doesn't do anything because we're stitching two functions together. So let's make this brighter. Again, it just kind of looks like an add, and then it just sort of kind of looks like a subtract. Much clipping will happen here. So if you want something that's simultaneously add and a subtract, linear light's your thing. So hang on, might as well write this down somewhere. So, oops. Here's add, which is linear dodge. And linear burn. You just sort of stitch them together. Some sort of weird Frankenstein's monster. It's fine, don't worry about it. Don't think about the join. And similarly, you can get, by combining color dodge I can spell. And color burn, which again are basically divide and the opposite of divide. By stitching these together, you get vivid light. because they couldn't call it color light, because that would make sense. So yeah, that's basically how you make the approximately 75% of these things. Is there music? Should be music. No? More? There we go. So yeah, these are the functions if you want something that does simultaneously make things brighter and make things darker. These are the ones you can use, the hybrid blending layers. Yeah. Looks like some of the equations we've worked on for curve fitting and numerical analysis. Yeah. They're nice. I like them. Now, bear in mind, again, when I say make things brighter and make things darker, I'm talking about this channel by channel. So it works on the reds, it works on the blues, and it works on the greens completely separately. So, if I were to take this picture of the cat and take a color which is 50-50-50, so that's 126, 126, 126. In our notation, that would be half, 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 and just make it all the reds like that, and set that as our thing. And then what we're going to end up doing is we're going to end up affecting only the reds of our image. We're going to be making those, you know, the linear light effectiveness, as it were. So we'll just end up basically existing with only the reds, and the greens and blues are going to get sort of ignored. You can do exactly the same with the greens and blues, and so on and so forth. Yes. So Kitten del Fuego. And the same works with every single layer I have mentioned up to this point. When I say make things brighter and darker, I mean per channel. So the more you start thinking about colors in terms of RGB, the nicer blends you can end up getting. Because again, if you start blending together images on one layer that are mostly green and images on another layer which are mostly not green, you're going to end up with something that looks grey. So yeah, do bear that in mind. But other than that, I think we're pretty much done. Let's do graphs. How am I going to do graphs? Let's work this out. So there's a Google thing. GeoGebra is what it is. This might take a little bit of explaining, but hopefully we can get it to make sense. Okay, so I'm gonna need to shift things around a little bit. Give me a second. Let's see if I can remember how to do this. I don't have any proprietary 3D graphing software, unfortunately, anymore. It's very expensive. Try and get this as close as we can to the edge, because we only care about 0 and 1. And everything in between. Oh, this is a weird interface. No, I don't want to go up and down. I want to refresh. It's a fiddly old thing. But hey, it's free. What are you going to do? Right, that'll do. I'll explain what all these things are in a second. And then I will plot every single layer style we have talked about, because they look nice. And it helps to have a visual representation of brightnesses and darknesses and all these things. Okay, so. Oh no, I don't want to zoom out, do I? That doesn't work. You're not going to let me move things down now, are you? Because you're like that. That's fine, no worries. Okay, so. Along this axis, is going to be the brightness of the color you've put in on the RGB spectrum. So it goes all the way from black over here to white over there. This is when I say the color you put in, I mean the color on the bottom layer. So this red line is going to be the brightness of the color on the bottom layer, and this green line is going to be the brightness of the color on the top layer, the one with the blending style. And the height of this is going to be how bright the output is. So in this particular instance, it doesn't matter. This is nothing. This is what happens when you have nothing on the top layer. It doesn't matter what this top layer is. We are assuming there's nothing on it, so nothing's going to change. It's going to be exactly the same all the way through, If your input colors, if the color on the layer below is black, you're going to end up with black. If it's white, you're going to end up with white. If it's 50%, you're going to end up with 50%, so on and so forth. Okay? So this is our baseline. This is just the color that sits underneath. Okay? Does that make sense? Because this is basically going to be how we're going to compare all the ones that come later. So, right. So here's normal. This is just sticking a top layer on top of another one, a layer on top of another one without caring. So it's exactly the same thing, but we're ignoring the layer below. There's no correlation here at all, unless, except along this line, which is when the top and bottom color are the same. That's just a coincidence. That's not particularly helpful. Let's add things together. Okay, so if we add two colors together, hang on, let me just get this to be nice and neat. If we add our colors together, they get brighter, which means they go further up than where they were before. If we start off with a black, if we try and add black, which will be over here, we end up with exactly the same color we started with, so that it intersects with the color that we had before. Otherwise, everything's going to get brighter, and this is what I mean by clipping. Everything that has disappeared here is too bright, and that becomes white. It's gone far higher than we can possibly actually use in the computer, and it's just been completely lost. So this is data that is lost if you blow out the picture. This is the angel kitten effect. So not ideal. Subtract, same thing, only the other way around. And there it is. So it gets darker, it intersects again. If you try and subtract black, nothing happens. Why are you over there? Oh, I zoomed out. It moved around, how dare. How honestly dare. Get rid of add for a second, give it a little bit of time to sort itself out. Okay, so yeah. So subtract makes things darker. Anything below this plane, this grey foggy thing, is going to be just turned into black. It's going to be clipped to black. So it just makes things darker. That's what that does. Multiply, on the other hand, makes things darker, but there's no clipping, and it's very smooth and very nice. All of the colours are there, but if you input black, it just turns to black. It doesn't matter what your original colour was, it'll be black. If you multiply with a white, it'll just be your original colour, because that's where these two things join. And everything in between is very smooth and very nicely behaved. Multiply is pleasant. I like multiply. Similarly, screen. This is what I mean by screen being the opposite of multiply. Well, let's give it a good colour. So screen looks very similar to multiply, only it's sitting on top of the original colour, so it's making things brighter. But it's basically the same sort of looking thing. There's a nice little spinning effect. So the yellow is screen, the orange is multiply, and the blue is the colour that we started with. So you can sort of see that they're basically the same, just flipped around, which is what we wanted. Yeah. Now let's look at divide. Okay. There it is. Look at the absolute mess of divide. There's a lot of clipping. A lot of clipping going on here. It's basically the same amount as clipping as add. Same amount of clipping as add. But it's got the contrast. It's got this sort of slope here. This is what I mean by dark colours stay darker for longer. So if your starting colour was quite dark along this red line here, and we sort of look here, you see there. The dark colours kind of stay darker, and it takes a while for them to sort of accelerate up to be brighter, whereas bright colours are like, oh, I've already clipped. You've got this lovely sort of gradual slope to it. So there's a contrast, but it does clip. And if we compare that to add, here. Ooh, no. Oh, well, no, we don't want divide, do we? We want color dodge, which is the same thing as divide, only we invert our input layer. It's the same thing, but we just sort of flipped it around a bit. And then we compare that to add. They're the same color. That's annoying. Randomly choosing the same colors is not ideal. What can we use? We can use a green. So yeah, you can see that color dodge and add are kind of working in the same way, but color dodge / divide has this slope to it. It has contrast. This is Green Path, I think. Yes, this is Green Path from the Hollow Knight soundtrack. So yeah, add and divide are very similar. It's just that divide has a nice smooth contrast to it, so things don't get blown out. Well, they get blown out, but they don't wash out at the same time. Right, now for the useful ones. The ones that actually demonstrate something. Overlay. Hopefully I get this right. Oh, yeah, that looks about right. Let's give it a color that's not the same as the color we have before. Honestly. What do we want? We'll go with that. Nice. Okay, this is overlay. And as you can see, it looks like two functions stitched together. There's a seam going along the middle. This is our kind of screeny thing, and this is our kind of multiply thing. But this is what overlay essentially looks like. It makes things, again, if you put in a 50% gray on your overlay layer, it'll be exactly the same as the color you had before. This is the intersection with the original color. If it's any darker, it'll go down and it will get darker. And if it's any brighter, it'll get brighter. And that's what we wanted. We wanted a function that did both. Exactly, I really like this graph, particularly if I show you like this. And this is what I mean by dynamic range. If your input color, if the color on the layer below is 50%, you can make it all the way black, you can make it all the way white, you have complete tonal range. But if you get any brighter than that, suddenly you can't make it dark enough anymore. If you go any darker than that, suddenly you can't make it bright enough anymore. So this is the limitation of overlay. Is you have full tonal range if your colors below are kind of 50%. But if it's too bright or too dark, you lose range. Compare that to hard light. Actually, again, I can just copy paste this. Oh, I didn't show you the cool thing either. Oh, I'm going to show you the cool thing after this. Hard light is exactly the same. We just deal with the input color over the top color over the bottom color. As you can see already, full tonal range everywhere. You get complete control. So yeah, if you start with a black, you can turn it white. If you start with a white, you can turn it black. This is hard light, everybody. And if you look at the graph, it's exactly the same here, and it's exactly the same under here. This is this checkered pattern, they're kind of intersecting, but it's what happens in the sort of extremes, the very darks and the very lights that, yeah, hard lights goes hard. So yeah, it's very similar to overlay in some ways, but it diverges at the extremes. This is why I wanted to show you the graph, because I think this is very helpful. Now compare that to soft light. We'll get rid of hard light for a second. X, Y is equal to, let's see if I remember what I'm doing. 1 minus X, Y, plus X. There it is. So soft light, on the other hand, doesn't go toward the extremes, and it just kind of sits in the middle. It's got this sort of nice gradual change from one to the other. It doesn't have the big extreme in the middle, but by the same token, if you move away from the middle, it's still kind of the same range. You don't have, it's the introvert. Yeah, it's consistent, but it doesn't draw attention to itself. Again, compare that to hard light, which is just full on in every aspect. So yeah, it's just like soft light is just an overlay, but just softened out, smoothed out. You don't get a lot of change from a soft light layer, but you also don't get a lot of erratic behavior. So yeah. So that's why I wanted to show you the graphs, because they're nice. Yeah, so there's graphs and such. I like them, they're nice. Again, there are plenty of other layers. There are plenty of other layer styles I haven't talked about, like pin light. They behave very strangely. I'm not going to go into them. There are things like hue, saturation, and color hue, saturation, and brightness, which directly affect only hue, saturation, and brightness. Color, which I think is hue and saturation, but leaves brightness the same. Yeah. That's basically that. There is one more thing I wanted to demonstrate, which is demonstrated via this picture, which I did post on Discord before, but I think is very nice. Try says that this hurts his eyes, so fair warning. But I quite like it. This demonstrates that hard light and overlay are basically the same thing, you just change one parameter. If you remember, the formula for hard light and overlay are identical. You just ask whether or not we're looking at whether the color below is above or below 50%, or whether the color above is above or below 50%. And that means that if you take two layers, layer A and layer B, the layer A on top of layer B, and set layer A to hard light, that's exactly the same as swapping them around, having B on top, and setting B to overlay. So, again, hard light and overlay are essentially the same thing, it just depends whether or not you have it on top or below. So, for example, here's this pinky colour here. If I put that pinky colour on a hard light over a yellow, I get this. Or I can put the yellow on an overlay over the pink, and I get exactly the same colour. You can see I connected them up to show that they're identical. Similarly, this pink over the green with a hard light is the same as the green over the pink with an overlay. It comes together with this sort of soft purple, and so on and so forth. I wanted a way of demonstrating that, so I made this. So yeah, hard light and overlay. Just swap the order of the layers, and you can swap around whether or not you're using hard light or overlay. Again, this doesn't work with transparency. Transparency makes things a bit more complicated, but for now, it's perfect. I quite like it. And that's basically it. That's all of the stuff I know. Hopefully that was useful. Hopefully it made sense. Is there anything you want to know that I haven't properly explained? Or should we do Drawful? For like half an hour, we can have a couple of games. Basically, oh hang on, let me get the picture up. I made this. This is basically everything you need to know. What I just said. Thank you for the applause. Thank you for the sarcastic applause. This is all you need to know. You have add. If you add and subtract are compositional opposites, but the functional opposite is linear burn. You stitch add and linear burn together, you get linear light. Screen and multiply are opposites. If you stitch them together, you get soft light, overlay, and hard light, depending on which way you want to do it. Divide and color dodge are the same thing, but if you want to take the opposite of color dodge, you get color burn. And yeah, and then you can combine those to get vivid light. So you have these this little family tree that I made. Are there any functions that aren't part by part? No, all of the ones I've looked at work completely individually on R, G, and B. As I said, there are these ones here. So for example, hue. That will just affect the hue of the thing underneath. It won't affect the saturation or the color. How that relates to RGB is very complicated, and that will have a convoluted way of messing around with RG and B. It's just you need to think of a different way of transforming the 0, 1 cube into kind of cylindrical coordinates. It's because hue is, it goes from 0 to 360 or 0 to 2 pi if you prefer, and then loops back around again, whereas saturation and brightness are 0 to 1. So you have to map the cube to the cylinder in a way that makes sense. There's kind of singularities there at white, but it doesn't matter. So yeah, if you want to go through mapping 3D space into slightly more complicated 3D space, you can work out exactly how that works with RGB. I will probably do that one day, but I haven't done it yet. And there are things like pin light and hard mix, which do very strange things, involving checking to see whether or not your red value is brighter than the red value of the one before, and if not, if it's the largest of all three values in the RGB, then it will replace the color below. If not, it will just cancel them out altogether, and very weird things happen. There's a lot of if-then statements with those ones. Oh, and also I made this as well to demonstrate the different contrasts of these things, of these Frankenstein's functions. So, like I say, linear light, it basically, everything sort of changes linearly. Soft light is very little change altogether. Overlay, you get a decent change, and the contrast is sort of preserved. Hard light, the dark colours stay darker for longer, the bright colours stay brighter for sort of less long. And then you have vivid light, which is like full contrast, everything gets blown out and clipped and all that sort of stuff. So this is a kind of side-by-side comparison. Hard light's a bit tougher when it comes to darkening bright colours than overlay or soft light. And vivid light's just sort of doing its own thing. This is the color burn, color dodge thing. So this is kind of what color burn looks like. This is kind of what color dodge looks like. Yeah. Vivid light's a special boy. Oh yeah, that's the high contrast, as I think I put here, didn't I? Yeah, divisional modes. High contrast clipping. That's them. Also, the divide should be in this one because they're the same. I don't know why I put it there. To make it symmetrical, probably. Oh no, I could just swap those around and then have it. Oh, and subtract and linear burn are basically the same thing as well, so I can change this and make it nicer. Good. It's very interesting, and I've explained it brilliantly. I hope so, because I found it very, very interesting myself, and I hope I've gotten the ideas across without being too mathsy. Let's do Drawful. Do you want, or some other Jackbox game? I don't know. People up for that? Let's turn the music off. Yes, should we do Drawful? Drawful was fun last time. Let's do that. So let me change this back here. Class is over. Time for fun. Yeah, it's the end of the year. We'll get the TV out. We're watching the first 50 minutes of Napoleon Dynamite or whatever. Everyone draw on the right whiteboard. Yeah. Have fun. Need to run and shower. Have a wonderful shower. Thank you for popping along. Hopefully I didn't give you too much of a headache. Okay, so let's put places I can actually see things. That would be great. Enjoy being less stimky. Okie doke. So, is it still Drawful here? Eventually, there it is. Yay. Okie doke. Okay, so get up jackbox.tv on your favorite web browser. Whoops. That's no longer my favorite web browser. Shock. And you can join with the appropriate room code. So put in your name. It's the Sassy Owl. Cool. So yeah, go to jackbox.tv. Oh god, do teachers do this? Can you imagine, like, at the end of term, a teacher going, let's play a Jackbox game, and the kids can join, and they get their phones out, and... How am I finding the new browser? It's almost exactly like Chrome, only it tells you how many things it's blocked, which on YouTube is 99 plus. It's great. Because I remember when I was teaching at my old school at the end of term, one of the maths teachers, for like 10 minutes at the end of class, just put up a bunch of Simon's cat animations. I don't know if you've ever seen those. That was nice. Right, so let's find out what this code is. Ooh, let's begin! Play Drawful! The code is 12. Everybody type in 12. Shwhoop, shwhoop. Oh god, now I've got to draw myself again, haven't I? We're jackboxing because I finished my lecture. Anybody and everybody, feel free to Atlas. And then there was silence. Whoops, that broke the silence. Whee!
Oh.
Hello.
I can't draw myself, I'm terrible. Oh, look at all these good things. Yeah, our Ragdolls is pretty darn spot on. And then there's Good Atlas and the Good Business Crow. And Miss looking as enthusiastic as ever. So yeah, is everyone who's in? There's a question. Everyone who wants to be in. I've lost the ability to speak. I've been speaking relatively coherently for an hour and a half. In that case, let's go. Go! Boom.
Well, I see it's time for some drawful. I'm excited to see what
It's time
you
for
guys
some
can draw. I'm gonna get
drawful.
this thing started. Okay.
I shouldn't make fun.
I sent a prompt to
What?
each of your devices. Something kind of weird. Like frat bros or Mad Max Fury Road cosplay. Draw a picture on your device that would have that title, and when you're done, hit send. You'll get points for each player that can correctly guess your title. So, go! Do it! And hey, it's never too late to join the audience. Or, actually, sometimes it is too late, but it's not too late yet. Oh!
Okay. I think that was alright. Are you joining the audience to turn nervous and draw? That's absolutely fine, Kiro. Nobody's pressured to do anything. Hopefully you can have fun in the audience. No, I'm using a stylus and I'm terrible. So don't worry about it. I guess? Did you get another band? I'm kind of proud of mine because it's very simple, but at the same time kind of gets the idea across, maybe. We'll see. You didn't get a
Oh,
band.
good. All of you got your drawings in on time.
Okay.
Let's see the first
What do we got?
one.
We have.
Now, use your device to type in whatever the heck the prompt for this drawing could be.
Oh no. Oh no.
Oh!
Hello!
And here are your choices. One of them is the real title.
Is it Centaurs in a Line? Wrong half. Using all of the centaur, 2 guys in a horse costume, or 2 bros in a horse costume?
Hello!
Oh!
Sincerely hope it's one of the latter 2.
And here are your picks.
Oh, you got me. You got me with your overly specific terminology. Everyone else got it. I thought bros sounds more like what the game would write, no? Well done, everyone, though. And well done, Crow. Good job. Absolutely thought it was a centaur.
Let's take a look at our next drawing.
That came together at the last second, and I love it.
Hello!
Oh!
Ow.
Okay, here are your choices.
Is it Sun shooting Earth, shooting for the Earth, Revenge of the Sun, plasma gun, or solar flare gun?
Hello!
Oh! Let's see what people picked.
You can see who's gonna trick me again. Oh, Crow! Good job. That's a good one. Revenge of the Sun. That was me. Yay! I got you though, so we're equal. Was it really that? It was actually that simple. Okay. Solar flare gun was too clever, I think, for the game. It was that simple. Oh, I feel bad. That's mine.
Next up,
My screen says you drew this. You. Cheers.
oh! Here are your choices.
Is it time stopped, time to get a new watch, time skeptic, deja vu, or clock watching?
Oh! Okay, who picked what?
It's not time to get a new watch. Crow, you're doing very well. You were timed out, oh no. Well, you're in the audience, so you can get back, yeah?
Oh!
It's not time stopped. You were going to pick time stopped. Well, you would have given Ragdoll some points. It was deja vu. How did you draw deja vu?
Have we done this one before? Did I say this afterward?
Time skip. I like time skeptic. That was fun. That was Chip. It was you. Look at Crow soaring above us, mockingly. What's oh?
And now, this one.
Oh no.
Hello!
Oh!
Love sets. Oh.
And here are your choices.
Is it the sad balding porcupine, the bald porcupine, balding porcupine, or balding hedgehog?
Hello.
Oh. And here are your picks.
I was the dissenter. I didn't think of it as a porcupine. Thank you for the points. Oh, crow. Ah, you got me. What was it? That was bald pork, yes. Difficult to draw without having some quills in it, so yeah. We all knew the gist of it though, which feels kind of bad in a sense. We knew it, but you didn't get any points.
Put in your titles now.
Okey-dokey.
Hello.
You drew this, enjoy it. No, you must. The game has told you to.
And here are your choices.
Is it toothless mare spitting teeth, top hat man inhales crisps, coughing up bananas, or snowman no teeth?
Hello.
Oh, teeth. It's tricky to draw on these things. Top hat man inhales crisps.
And here are your picks.
Hello.
Thank you for the pity vote. Spitting teeth is an expression? No, miss. Ah, bother. I was gonna go for that one. Ah, booger. You got it. You got it right. But Miss got all the points.
Your next round of
Oh,
drawing
one more.
prompts are
Okay,
ready to
right.
go.
Mm-hmm.
Oh.
Hello.
Sure. Sure. There were several ways I could go with that. Hopefully that makes sense. But not enough sense that people know. That was a drawing, yes.
What is
Thanks
it that
for
you're
your
drawing
drawing.
that's so important? Drawings in?
Is indeed the way
Let's
that's
get
the way
to the
everyone
part.
feels after this. They're not easy problems. What do we got?
Enter your
Oh.
titles now.
Hello.
Whenever you don't get a band, you get some weird nonsensical prompt you don't know how to draw. That's
Okay.
Pretty much it,
Here
yeah.
are your choices.
Is it God's best friend, a cup of coffee in the sun, hail the size of baseballs, the sun comes out for baseball, sharing a hamburger with the sun.
Hello.
Really wish you could erase, yes. If
Let's
only.
see what people picked.
What do we got? Is it the sun comes out for baseball? No, but thank you. My chair is very squeaky, I apologise. Is it sharing a hamburger with the sun? No, Chib. At least it wasn't Crow.
Oh.
Wow. How do you draw that? You had my sympathies, Ragdoll. You don't know. Yeah.
Let's take a look at our next drawing.
What is it? What is it? What is it? You drew this. This too shall pass. Yeah. I like that one.
Oh.
Like I could have drawn this in several different ways, and several different interpretations. God's best friend, like. Can't think of a simple drawing that would get
here are
that
your
across.
choices.
What is it? Corded tank. Fucking Johnny forgot how to put the plug in. Oh, forgot to put the plug in. Electric tank. Empty in the tank. My tank is empty.
Oh. Okay, who picked what?
It's not emptying the tank. Well done, mister. You got the crow. Apparently I know how to draw an electric tank. Go me. You wrote your tank is empty. When two people write roughly the same thing.
And now,
Fair enough.
another drawing.
I got too close, apparently.
Hello.
There we go. So well done. I mean, I know what this is. Squeaky chair, please. There we are. What is
Here are
it?
your choices.
Nut hammock, peanut hammock, sexy hammock, slingshots for squirrels, or peanut hammock.
Hello.
I think this says more about the person who wrote these prompts than it does about the drawing.
And here are your picks.
Said I got too close. How dare. Wait, hang on. Wait, what? Wait. No, okay. How was that too close? Oh, it might have said I got too close to the real or someone else's answer, maybe. I think Chibi, you might have put yours in before me. Oh well.
Type in a title.
Of course, Crow got that prompt. Yeah. Try to draw it like a. I get you. It's difficult. Yeah. I need to write something now.
Oh.
Hello.
Hello. But then it just didn't. Yes, that's the game. I've just realised that my name looks like creepy.
And here are your choices.
What is it? Moon golf, golf under the stars, golf on the moon, golf star, future golf.
Oh.
Hello.
And here are your picks.
Is it golf under the stars? No, but thank you. Only one. But that's enough. Haha. Ah, miss. I give you the points that Crow gave me. Miss, who are you going to give your points to? Oh, the actual answer. How dare. Well, there you go. 3
Wow,
people. That's pretty good.
Still not interested in that.
Yeah.
Put in your titles now.
Okay.
Oh.
Hello.
You lost it all. You could win it all back.
And here are your choices.
What is it? Grandpa Christmas tree, sick of Christmas, Tinsley Tim, lame Christmas, broken Christmas.
Oh.
Hello.
Get
Let's
with
see
that.
what people picked.
Oh, look at that! Well done. Spot on.
Oh.
I think. Oh no! Oh hey, this is me. Somehow, with that drawing, I won. But who was most liked? Important. It was Chib. Kill surprise. Cool. Look at us, just sitting at the top, taking all the points and all the likes. That was pretty close at the top. Yeah. I feel bad for Ragdoll. God's best friend. Like, what do you do with that? Yeah. So that was fun. We should probably end the stream. Yeah, it was rough. Sorry, Ragdoll. Yeah. So let's do that. Let's end the stream. Boom. Thank you for coming along. Shush game. You have been disconnected. Art or philosophy, we just don't know. Me, hello. That is my name. That name again is me. Thanks for the stream. I'm glad it connected because I had a really good time working this stuff out, and I wanted to communicate that. So hopefully for those of you who missed the beginning, hopefully, and are interested in learning about blending styles, feel free to watch the VOD. I'll upload it as soon as I can. It's nice hearing me talk. I'm pleased. Speaking of which, tomorrow we've got Dishonored. Saturday we have Forest of Doom, but on Sunday the stream is cancelled, as you can see. And I believe Chibi wishes to take that Sunday slot. So we'll be hearing the Chib talk. Yeah, and we know that the Chib is the most liked here. So yeah. You tell your enthusiasm really shone through. It was, yeah. It's nice to have a little project like that, you know? Where you're learning something. I haven't learned anything for ages. Even when I was at uni. Last 2 years of my PhD, I just spent doing calculations. I didn't learn anything. I want to learn more. Went over your head, but you reckon it was super helpful for the art piece. That's fine. It's not for everyone, you know? If you don't do the digital art, it's not going to make sense. But I'm glad you stuck around, and yeah. Just you constantly saying Beeb. That's fair enough. So yeah, thank you for coming along. I'm glad it was not too confusing. And the VOD will be available if you wish to go over it again. Again, the reason I shared this is because I found it very interesting, and it was very helpful for me trying to work out what on earth these layers do and how they're related to one another. And once you actually put them in a decent structure, you know, you've got the linear ones, the multiplicative ones, the divisional ones. You then have their opposites and the Frankenstein's monsters. And that's all you kind of need to know, you know? But no one explains that, so I thought I would. You're very welcome. Thank you very much for coming to lecture and staying to end. Yes. Have a wonderful time. I'll see you possibly tomorrow if you wish to go to that stream. And if not, have a wonderful time doing whatever it is you're doing elsewhere. Have a good day. Have a good week. Enjoy yourselves. Goodbye.